Hi, this is Mr. Shumway. This video clip explains how to calculate the energy needed during heat transfer, including phase changes. For example, to warm ice from below freezing to above the boiling point, you would have to provide not only the energy to heat up the ice, and then the water, and then the steam, but also the energy to melt the ice and to boil the water, to change the water to steam. The energy required to melt a material is called the latent heat of fusion. The energy required to change a material from a liquid to a vapor is called the latent heat of vaporization. So, for example, to convert 2 kilograms of ice at -10 degrees Celsius to steam at 110 degrees Celsius, we first have to warm up the ice to the melting point, then provide the energy, the heat to melt it, and then warm up the water from 0 degrees to the boiling point, and then provide the energy to make the transition from water to vapor, and then heat up the steam. Okay, so let's heat it up from -10 to 0 degrees first. Ice has a heat capacity of about 2,000 joules per kilogram per degree. So if we multiply the heat capacity, joules per kilogram, and degree, times the degrees, if we multiply that by 2 kilograms, then the kilograms cancel, and multiply that by 10 degrees, then the degrees cancel, and we just have joules, units of joules, and the value turns out to be 42,000 joules. And then to melt ice, we have to provide 333 joules for every kilogram, and we're going to melt 2 kilograms. So we'll end up with just joules, and we'll have 666,000 joules to make that ice change to water. And then to warm up the ice from the melting point to the boiling point, there's 100 degrees. So if it takes 4,200 joules for every kilogram to warm up 1 degree, and we're going to warm up 2 kilograms, 100 degrees. The degrees cancel, the kilograms cancel, and we just have joules for a value of 840,000 joules. And then water turning to steam takes 2,300,000 joules for every kilogram. And we are melting 2 kilograms. So if I multiply that by 2 kilograms, I have 4,600,000 joules. And then to change the temperature of steam, it takes 2,000 joules for every kilogram for every degree. And we're going to heat it from 100 degrees to 110 degrees, so we're going to change that by 10 degrees, and there are 2 kilograms. units cancel, and we just have joules. 40,000 joules. So then we add up the pieces, the 5. We found the energy for each of those 5 pieces, and then we'll just add them up. So I went ahead and wrote those values in. And as you line them up, you can see that vaporizing the water is the largest piece, by an order of magnitude, really. So depending on how accurate the answer has to be, some of the pieces can be ignored. On the computer for the quiz, we need to be within 5%. One way to make sure you're always within 5% would be to keep the first 3 digits, first 3 significant figures. And so in this case, that would mean that all of these would be significant, just to make sure we're okay. So we'll go ahead and add all those up.